We are continuing on with rational expressions. So we have simplified, multiplied, and divided, and now we are going to be adding and subtracting. So just as before, when we were following our same rules for fractions with multiplying and dividing, it is going to continue to follow those rules for adding and subtracting. Namely, we have to have a common denominator in order to add or subtract fractions. So for example, 1/3 plus 8/3, my denominators already match, so to add those fractions, the denominator stays the same, and you add your numerators. 1 plus 8 is 9. 9 over 3 does simplify to 3. Now, what do you do when you have a set of fractions that don't already have a common denominator? We need to make one or find one, and we're going to look for the least common multiple between those two denominators. So 5 and 7 don't share any factors, so the least common multiple is going to be the product of the two. So 5 times 7 is 35. So that's going to be my common denominator. Our first fraction, we're going to have to multiply by 7 in the top and the bottom to get to 35. And in our second fraction, we're going to have to multiply by 5 in the top and the bottom to get to 35. So we now have a common denominator. So my denominator will stay the same, and I'll subtract my numerators. 7x minus 20. There's no common factors here or anything that I can factor out or simplify, so that is the final answer. So what do we do when we have our rational expressions? Well, we're going to follow these same rules. If they already have a common denominator, such as on example A, I'm just going to keep my denominator the same and add my numerators. So that's going to be 16 plus z plus 11 minus z. So the z's cancel. 16 plus 11 is 27. And I don't have any common factors to simplify here, so it stays 27 over 5z. All right, B. Again, my denominators match, and this time I'm subtracting these fractions, these rational expressions. So my denominator will stay the same. And I'm going to be subtracting my numerators. So I've got 3x squared minus 4x plus 6 for our first fraction minus. This is where you might make a mistake and end up with the wrong answer if you forget to do this step. We are subtracting this entire numerator, meaning you have to distribute that minus sign to everything in the top. So that's going to give us minus 2x squared minus 2x minus 1. All right, so let's combine like terms in our numerator. I've got 3x squared minus 2x squared. I've got minus 4x minus 2x. And I've got 6 minus 1 over x squared minus 2x minus 15. Now, let's see if we can simplify this further. Can I factor the top? Are there factors of 5 that add to negative 6? Yes. That's going to be negative 5 and negative 1. Now what about the bottom? Are there factors of negative 15 that add to negative 2? Yes. That's negative 5 and positive 3. So I factored. I have a common factor that I can cancel. So x minus 1 over x plus 3 is our final simplified answer. So that's when we already have common denominators, but when we don't, and they're not just numbers that we're dealing with here, we still need our least common multiples for our denominators to match. So the way that we do this is we look for, okay, what do these expressions already have in common? So between 6x and 2x squared, for example. Let's look at our constants, our coefficients in the front, 6 and 2. The least common multiple between 6 and 2 is going to be 6. And my least common multiple between x and x squared is going to be x squared. So here's my least common multiple. To achieve this, 6x would have to be multiplied by x, and 2x squared would have to be multiplied by 3. So there's our least common multiple. Now, x squared minus x and 2x minus 2. When we add in a binomial here, so an addition or subtraction, what you're going to want to do is take out the GCF for each expression to see what they already might have in common. So x squared and x, if I factor out an x, that leaves me with x minus 1. And 2x minus 2, if I factor out a 2, that leaves me with x minus 1. So they already share x minus 1, so that's going to be part of my least common multiple. Then I've got an x and a 2. So to get these to match and become my least common multiple, the term on the left will be multiplied by 2, and the term on the right will be multiplied by x. And there's my least common multiple. All right, one last practice before we put it into action. Again, I'm going to take out a GCF, and I'm going to factor this trinomial. So they already share an x plus 2, and then to get them to match, to be the same, we're going to need that 3x and another x plus 2. So we would multiply the expression on the left by x plus 2 and the expression on the right by 3x to get our least common multiple. All right, let's put this to use with some actual addition and subtraction here. So starting on example C, my denominators don't match, so I need the least common multiple. There's nothing I can factor here, so the least common multiple is going to be the product of the two, x minus 3 times 3x plus 4. So the fraction on the left is going to get multiplied by 3x minus 4 in the top and the bottom. Minus our second fraction is going to get multiplied by x minus 3, also in the top and the bottom. So now my denominators match, and I can subtract my numerators. So my denominator is going to stay the same. And let's go ahead and distribute that x here. I'm going to get 3x squared plus 4x. And then again, you have to distribute the minus here, so I'm going to distribute negative 2 into both of these. So that's going to be minus 2x plus 6. Now let's simplify and combine like terms in the top. That's going to get us 3x squared plus 2x plus 6 over, if I FOIL out my denominator, I'm going to get 3x squared minus 5x minus 12. Now, we always want to check to see if we can simplify this further. So if I'm looking at my numerator here, this trinomial, am I able to factor it? Now, this coefficient is bigger than 1, so we would use our splitting the middle term method. And if I multiply 3 times 6, and I look for factors of 18 that add to 2, there are none. So this numerator is not going to be able to be factored, which means I'm not going to be able to cancel anything, and that is going to be my final answer. All right, let's do this again on D. Again, I need a least common multiple, and let's see if I can factor any of these denominators. X squared minus 1, that's a difference of squares. So that's the same thing as x plus 1 times x minus 1. So my least common multiple between my three denominators is going to be x plus 1, x minus 1, x. So our first fraction will need to be multiplied by x and x plus 1 in the top and the bottom. Okay. Our middle fraction is going to need to be multiplied by x plus 1 and x minus 1, also in the top and the bottom. And our last fraction is going to need to be multiplied by x. And it's getting kind of tight here, I apologize. Okay, so now we have our matching denominators, so we can go ahead and combine our numerators, x plus 1, x minus 1, and x. So this is going to be 3x distributed into the x plus 1, so that's going to give me 3x squared plus 3x. We know that x plus 1 times x minus 1 gives us x squared minus 1. So negative 2 to the x squared minus 1 is going to give us negative 2x squared plus 2. And then lastly, distributing that x into x plus 3 is going to give me x squared plus 3x. So let's combine our like terms in the top. 3x squared minus 2x squared plus x squared. It's going to give me 2x squared. 3x gives me 6x plus 2 over my denominator. Again, this is going to be x squared minus 1. Sorry, these two give me x squared minus 1. Distribute that x, I get x cubed minus x. Now, there is a GCF in the top that I can factor out, and that is 2. And that leaves us with x squared plus 3x plus 1. Now, I do have a trinomial in the numerator, but there are no factors of 1 that add to 3, so it cannot be factored. And here is our final answer. All right, last one, complex fractions. This is when we have a fraction being added or subtracted in both the numerator and the denominator. So when you're approaching a complex fraction, what you need to do is first get our numerator to be a single fraction, our denominator to be a single fraction, and then we divide our two fractions. So that's just our keep, change, flip. So let's start with just our numerator. X over x minus 3 minus 2 over 3. I need a common denominator, so let's look for that least common multiple. It's going to be x minus 3 times 3. So our first fraction gets multiplied by 3 in the top and the bottom. And our second fraction gets multiplied by x minus 3 in the top and the bottom. So I now have a common denominator. So it's going to be 3x minus 9, 3x minus 2x plus 6. So my final result is x plus 6 over 3x minus 9. This is now my numerator. All right, we turned our numerator into a single fraction. Let's do the same thing in our denominator. 10 over 3x plus x squared over x minus 3. Again, I need a common denominator. That least common multiple is going to be x minus 3 times 3x. So the first fraction gets multiplied by x minus 3. Our second fraction is going to get multiplied by 3x. So we now have matching denominators, so I can add these fractions. I'm going to get 3x squared minus 9x. That first fraction, when I distribute the 10, and then my second fraction, I distribute the x squared. There are no terms that I can combine in my numerator, but I'm just going to rewrite this in descending order, meaning the greatest to least exponent. Okay, and this is now my denominator. So what we have done is we have transformed this into x plus 6 over 3x minus 9 divided by 3x cubed plus 10x minus 30 over 3x squared minus 9x. Okay, that is what we have done, which means we're dividing fractions. So we're going to keep the top fraction the same. We are going to change that division sign to multiplication, and we are going to flip the second fraction upside down. And we are now multiplying rational expressions, which means we want to factor and cancel any like terms. So let's do that. Here I can take out a 3. Here I can take out a 3x. And I cannot factor this second denominator. So what can we cancel? We've got x minus 3, and a 3 and a 3. So what that leaves us with is x plus 6 times x over 3x cubed plus 10x minus 30. So you could leave it like this, or you could go ahead and distribute that x in the top. Either of those is fine. And here is our final simplified complex fraction.